Those who are online, are you able to hear me?
Yes, sir.
Yes. So I think we did problems till 7th. Right? Total. Okay. I need the values to tell answer them. Just positive answer. You have the question? Exemplar. Okay. I need to read it clearly if I have some key point in it. Yeah. So shall we proceed?
Yes, sir.
So how to solve this one? There are 2 point charges. QA is equal to 3 microcoulomb and QB is equal to minus 3 microcoulomb, which are located 20 centimeter apart in vacuum. Right. What is the electric field at the midpoint O of the line joining of the line AB joining the two charges? So I have a positive charge here. I have a negative charge here of values 3 microcoulomb, and you have a 3 microcoulomb here. So these two are separated by a distance of 20 centimeter. If I take this point to be O, then what is the electric field at the midpoint? See, electric field due to the positive charge is going to be away from it. Electric field due to the negative charge is going to be towards it. So electric field due to the positive charge is in the positive direction, and electric field, you can use my one. Electric field due to the negative is in this direction, this side, this side. So what is going to be the net electric field? Is it not going to be the electric field due to the positive charge plus electric field due to the negative charge, but in the vector form? So what is going to be the direction of, what is going to be the magnitude of electric field due to the positive charge? It is going to be KQ divided by R square plus what is going to be the magnitude of electric field due to the negative charge? I told magnitude. It is again going to be KQ divided by R square. It is going to be 2 times KQ divided by R square. I hope you understood. So one of the misguiding factors here is we will assume that they get cancelled out because it's a midpoint, but they don't get cancelled out because the charges are of opposite nature. Clear? So it is 2 times KQ divided by R square. So any doubt? Okay. So 2 into 9 into 10 power 9 into what is the value of Q? I'll take only the magnitude. 3 into 10 power minus 6, the whole divided by R square. R square is going to be, this distance is how much? 10 centimeter. It is going to be 10 into 10 power minus 1, the whole square. Am I right? So how much is it going to be? 18 into 3 is 54 into 10 power 3, the whole divided by, it is 10 power minus 1. They get cancelled, no? It's 10 power minus 2, sorry. So you'll have 10 power minus 1 the whole square, which will be 10 power minus 2. So answer will be 54 into 10 power 5. It's very high value. Okay. 54 into 10 power 5 Newton per Coulomb. This answer. So keep checking the answer at the back also. If there is any discrepancy, let me know. Is that right? Did we check at the back? Just have a bookmark there. So it is the 8th problem. 1.8. Correct, no? 54 into 10 power 5 Newton per coulomb. Did they give us a Newton per coulomb or volt per meter? Newton per coulomb. Okay. So that is another unit. So if you read the next part of the question, see. If a negative test charge of magnitude 1.5 into 10 power minus 9 coulomb is placed at this point, what is the force experienced by the test charge? So basically, when you know the electric field at a particular point and you know that you are placing a charge in the presence of electric field, right? Then force is written as Q into E. So Q is how much? 1.5 into 10 power minus 9 multiplied with the electric field is 54 into 10 power 5. So answer is going to be, so 1.5 you can write it as 3 by 2. Right, 2 means it will be 27. So 27 into 3 is 81. So 81 into 10 power minus 4 Newton. Right. So this is the magnitude, but it will experience a force in the leftward direction. In this scenario, it will experience in leftward direction. Had you taken positive sign here and negative sign here, it would have been the rightward direction. To put it very simple, it will experience a force in the direction opposite to the electric. Okay. Shall I proceed? Shall I proceed?
Yes, sir.
So listen, a system has two charges, QA and QB, both of same magnitude, located at the points 0, 0, minus 15. So if I take the system to be like this is 0, 0, minus 15, and this point is going to be 0, 0, plus 15. And here the charges are going to be 2.5 into 10 power minus 7, minus 2.5 into 10 power minus 7, right? What are the total charge and electric dipole moment of the system? What is the total charge? Total charge is going to be equal to 2.5 into 10 power minus 7 plus negative of 2.5 into 10 power minus 7. Answer is going to be a 0. Right. What about the dipole moment? So what about the dipole moment? So P is equal to Q multiplied with 2A. But here what I'll do is, basically it is the charge multiplied with the distance of separation between. So what is the magnitude of each charge? It is 2.5 into 10 power minus 7 into, what is the distance of separation between them? This is going to be 15 and this is going to be another 15. So it is going to be 30 into 10 power minus 2 meter. Right. So it is going to be 2.5 into 30 is going to give us 75. It's 25 into 3, no, 75. 10 will take this 25. So into 10 power minus 9 Coulomb meter. So 75 into 10 power minus 9 Coulomb meter. As I told, please keep checking the answer. He checked the typing. You have a bookmark there, no? Like how you have for other. Maybe you can paste your cap. Clear with this? Shall I proceed?
Yes, sir.
An electric dipole with a dipole moment of 4 into 10 power minus 9 Coulomb meter is aligned at 30 degrees with the direction of a uniform electric field of magnitude. I think it's 54. Right? It's 54, right? 54 into 10 power minus 1 Newton Coulomb. Calculate the magnitude of the torque acting on the dipole. It's very simple. So if you look at the solution for this, you have an electric dipole with a dipole moment of 4 into 10 power minus 9 Coulomb meter. Okay. So it is aligned at 30 degrees. So theta is equal to 30 degrees with the direction of uniform electric field. With the direction of uniform electric field of 5 into 10 power minus 1 Newton per Coulomb. Then this is 10 power minus 4 or 4 up. This is 10 power 4. Okay. Simple, no? They have given everything, just substitute. Plug in the values. Torque is equal to P sine theta. Done. They're asking only the magnitude, no? Calculate the magnitude of the torque acting on that. So P is 4 into 10 power minus 9 into E is 5 into 10 power 4 into sine 30 is half. Cancel this 5, no? So this will be 2. So 5 into 2 is 10 into 10 power minus 5, which is 10 power minus 4 Newton meter. It is 10 power minus 4 Newton meter. Clear with this? Is there anyone having doubt? Is everyone clear, able to solve one more? Shall I proceed? Right. Okay. A polythene piece rubbed with wool is found to have a negative charge of how much is the value? 3 into 10 power minus 7 Coulomb. There is an alignment issue here. So 3 into 10 power minus 7 Coulomb. Estimate the number of electrons transferred from which to which. That is the first part of the question. Is there a transfer of mass from wool to polythene? That's the second part of the question. So basically, what is the charge that is attained by the polythene? It is 3 into 10 power minus 7 Coulomb. Estimate the number of electrons transferred. So wherever you need the number of electrons, use the quantization of charge. Q is equal to N into E. So it is going to be 3 into 10 power minus 7 is equal to the number of electrons multiplied with the charge of each electron, 1.6 into 10 power minus 19. So here we can approximate this 3 to 3.2. So obviously it is going to be somewhere around 2. So 2 into this 10 power minus 19 will go to the other side as 10 power 19. 10 power 19 into 10 power minus 7. It's 10 power 12 is equal to the number of electrons. The answer in your textbook might be slightly lesser, be 1.9 something. They gave 2 only. Be somewhere around 1 point. They gave same thing. Okay, then it's an approximated. Is this 3 or 3.2? 3 only, no? Okay, that's an approximated value then. So 2 into 10 power 12 is the number of electrons that have got transferred. And secondly, they asked from which to which. So electrons have got transferred from where to where? From the wool to the polythene. Because polythene is the one which has gained negative charge. It has taken the electrons. So electrons have got transferred from wool to polythene. So answer to this is wool to polythene. Next, is there a transfer of mass from wool to polythene? Yes. Why? Because it has lost electrons. Yes, I can say because wool has lost electrons and the polythene has gained electrons. That's it. Shall I proceed? So two insulated charged copper spheres A and B have their centers separated by a distance of 50 centimeters. What is the mutual force of electrostatic repulsion if the charge on each is 6.5 into 10 power minus 7 coulomb? The radii of A and B are negligible compared to the distance of separation, meaning the charges are considered to be point charges. Okay, so there are two spheres where the distance between their centers is separated by a value of 50 into 10 power minus 2 meter, 50 centimeter basically, right? Yeah, the charge is found to be 6.5 into 10 power minus 7 coulomb, and here the charge is found to be 6.5 into 10 power minus 7 coulomb. So they're asking what is the mutual force of electrostatic repulsion between them. So to calculate that, force is equal to, we know the formula, it is 1 divided by 4 pi epsilon naught into Q1 into Q2, the whole divided by R square. So F will be equal to 9 into 10 power 9 into Q1 into Q2 is going to be 6.5 into 6.5. I would suggest you to deal with fractions or exponents. So 6.5, I will write it as 13 by 2 into 10 power minus 7. And it is going to be another 13 by 2 multiplied with 10 power minus 7. The whole divided by 50 into 10 power minus 2 is 5 into 10 power minus 1. So it is 5 into 10 power minus 1 the whole square. Right. So here I don't see any values that are getting cancelled in the first place. Okay. So this part I'm leaving it to you because I don't want to go and waste time. So those many Newton is going to be the answer. Right. Now, the next part of the question is, what is the force of repulsion if each sphere is charged double the above amount? Meaning, initially if the charge was Q and Q, now the charges are going to be 2Q and 2Q. Now here what is happening is, if I call the new force as F prime or F dash, right, then it is going to be K multiplied with the new charges. 2Q into 2Q is going to give me 4Q square divided by R square. But remember, if I take the 4 outside, this KQ square divided by R square was exactly the previous force. So what is happening to the new force? F dash is equal to 4 times F. So whatever value you find here, you just need to multiply that with 4. Any doubt? Oh, distance is getting halved. I didn't see that. So then it should be R square by 4. So this 4 will go above, it will be 16 times. Suppose the spheres A and B in exercise 1.12 have identical sizes. A third sphere of the same size but uncharged is brought in contact with the first, then brought in contact with the second, and finally removed from both. What is the new force of repulsion between A and B? This is an important question. Listen to this. So initially, if I take the charge to be Q here, and if I take the charge to be Q here, right? So first of all, tell me what is the value that was obtained in the previous case. So what is this value? 4.5 into 1.5 into minus. Okay, let's remember this. Now listen to this question. So there are charges Q and Q, which is considered to be A and B. Now there is a third particle which is uncharged. So if C is brought in contact with A and then moved, then the charge will get transferred in such a way that the sum of both the charges is what you need to do, divided with, that is the average of these two charges, right? So now C has got how much charge? Q by 2. Now what is A left out with? A is left out with Q by 2, right? Now this Q by 2 is taken in contact with B and removed again. So what will be the new charge that will be available? It will be Q by 2 plus Q the whole divided by 2. I told you, you need to take the average. So Q by 2 plus Q the whole divided by 2, it will become 3Q divided by 4. Right? Then how much is the charge that is going to be present? It will be the same thing. No? Okay. So what is going to be the new force of repulsion between them? If I call it as F double dash, then it is going to be K multiplied with the new charge Q by 2 on A and the new charge 3Q by 4 on B, the whole divided by R square. Distance is the same, right? So this is going to be 3 times K Q square divided by 4 times R square, not 4, it is 8 times R square. So it is becoming 3 by 8 times F. So it is going to be 3 by 8 multiplied with 1.5 into 10 power minus 2. So when you calculate this, that will be the required answer. Is that point clear? Right? See, this is a very important thing that you need to understand. Is everyone clear with this? You need to take the average of charges. Which one? This one. This one. 3, 4 into 2 is 8. 3 by 8 times kq square by r square. Clear with this? Shall I proceed?
Yes, sir.
Good. Figure 1.33 shows tracks of 3. I need the textbook now. Just show it to me once. Positive charge, negative charge, trajectory of 1, 2, and 3. Positive charge, negative charge. Okay. Yeah, let's see. I didn't read the question yet. So figure 1.33 shows tracks of 3 charged particles in uniform electrostatic field. Give the signs of the 3 charges. So the first charge, second charge, and third charge. So first and second are negative, and the third one is obviously positive. Right? Which particle has the highest charge to mass ratio? So the answer to the second part is E by M ratio, or I'll write it as Q by M ratio, is highest for the charge which experiences maximum deviation. So Q by M ratio is the highest for the charges which experience maximum deviation. So which one is experiencing maximum deviation is what the question is. So how to do that is, in your textbook itself, what you can do is, the horizontal path is there, no? Draw an extended line like this and see which angle is more. That one will be the answer. So initially it is having a horizontal path, no? So which one is experiencing more deviation? That's the answer. Check. See, why is it so? Actually, the answer to that question is given in the 33rd question. Look at 1.33, no? 1.33, the next page. So there, you're able to see one expression, QEL square divided by 2Vx square, I think. So that is actual reason why the charge by mass ratio is directly proportional to the deviation. But as I told you, we'll not be doing the additional exercise problems. That's why I didn't go into the mathematical details, but I hope you understood this. Right. Shall I proceed? Okay, this one. This one, right? Yes. Consider a uniform electric field E is equal to 3 into 10 power 3 I cap Newton per Coulomb. So write this as E vector, right? What is the flux of this field through a square of side 10 centimeter on a side whose plane is parallel to the YZ plane? Suppose you have a square like this, right? As understand, this is x-axis, y-axis, and something towards you is taken as the z-axis, right? There is an electric field existing in this direction, right? Now, there is a square whose side is parallel to the YZ plane. So this is y plane, sorry, this is y-axis, and this is the z-axis. This both put together will give you the YZ plane. So there is a square placed like this, and electric field is like this. So when a square is parallel to the YZ plane, its aerial vector is along the x direction. Are you able to visualize it? So when there is a difference here, whenever they say a plane is, whenever they say a shape is oriented to a particular plane, its aerial vector will always be perpendicular to the plane. To put it simple, you have x, y, z in the three-dimensional space. If something is parallel to YZ plane, its aerial vector will be in the x direction. So if I have suppose x, y, z, if suppose the question says something is parallel to x, y plane, then its aerial vector will be in the z direction. So in this problem, what is happening? So aerial vector is going to be equal to, the side is 10 centimeter. So it is going to be 10 into 10 power minus 1, the whole square, times I cap meter square. Am I clear with this? Sorry, 10 into 10 power minus 2, the whole square, I cap meter square. So it is going to be 10 power minus 1, the whole square is 10 power minus 2 times I cap meter square. So what is going to be the flux value? Flux is equal to E vector dot A vector. E vector is 3 into 10 power 3 I cap dot A vector is going to be 10 square I cap. So answer will be 3 into 10 power 5 Newton meter square per Coulomb. So this is going to be the flux in the first case. Is that clear? So this is going to be the flux in the first case. Harini, what is the doubt? You're clear? Is there anything that is not clear? Which part did you understand? Did you understand? Are you able to visualize the question? No. See, there is a uniform electric field in the x direction. You have, let's say, there is a field going like this. In that field, they have placed a square like this. And how is that square? The plane of the square, how is it? Whose plane is parallel to YZ plane. So the square's plane is parallel to YZ plane. So how is its aerial vector? So that is why aerial vector, I took the magnitude. Why did I take this magnitude? Because it's a square. For the square, what is the area? A square. And what is the direction? I cap. So I did the dot product between them. So I cap dot I cap is 1. So multiply the scalar part. 3 into 10 power 3 multiplied with 10 power minus 2. Oh, it is 10 power minus 2. Okay. So it is 10 power minus 2 means it is going to be 3 into 10. That is going to be 30 Newton meter square per Coulomb. This is the answer actually. Got it? Right. Okay. Read the next part of the question. What they are saying is, you have the same square. What is the flux through the same square if its normal makes an angle 60 degree with the x-axis? See, suppose this is considered to be the normal of this square. So initially it was like this. Now this normal is making an angle 60 degrees. Observe. Observe. So initially it was like this. Now it is making 60 degrees like this, so that the electric field is still like this. Electric field is in this direction. When they say normal to the plane, they are indirectly speaking about the aerial vector itself. When the normal to the plane makes an angle 60 degree with x-axis, the aerial vector of the plane also makes the same angle 60 degrees with the x-axis. So to put it simple, the diagram will look like this. If this is how the paper is, right? This is how the electric field is, then this is how the aerial vector will look like. Then how much is angle? So what is going to be the flux? Flux will be equal to EA cos theta. So E into A I already know, which is 30 into cos 60 is going to be half. So answer will be 15 Newton meter square per coulomb. Clear? So it is going to be 15 Newton meter square per coulomb. Shall I proceed?
Yes, sir.
So read this question. What is the net flux of the uniform electric field in the previous question through a cube of side 20 centimeter oriented so that its faces are parallel to the coordinate planes? So if I take a cube like this, then the faces of this cube are parallel to the coordinate axis. So if I take, for instance, this to be the origin, right? This is Y, this is Z. Okay, if I take this to be the origin, if I take this to be the first side and this to be the second side, third, fourth, fifth, and back side is taken to be sixth, for instance. Okay, so what is the flux through the first side? We know that the electric field is in this direction. How much is it? It is 3 into 10 power 3 I cap. For the first side, what is the direction of aerial vector? Is it not in the left hand side? So flux through the first surface, can I write it as E into A 10 centimeter is 10 power minus 1 meter. So A into A into cos of how much? 180 degrees opposite to each other. Similarly, the flux through the second side is going to be 3 into 10 power 3 multiplied with 10 power minus 1 the whole square into cos of. So for the second side, this is the direction of aerial vector. It is going to be cos 0 degrees. Right. So here, if you observe, the answer will be minus 30, and here the answer will be plus 30. Where? Oh, it's 20. Okay. So 20 means 2 into this thing. I took the values from previous problem. Where? Centimeter I converted to meter. So you will have into 4 is what I need to do. So this will be minus 120 and this will be plus 120. Right. What about the flux through the third, fourth, fifth, and sixth? It is going to be 0 because electric field and area vector are perpendicular. So when you take the total flux into consideration, answer will be 0. Because you add these two values, it is 0. So when you have a question like this, the meaning of it is the number of electric field lines entering the surface is equal to the number of electric field lines leaving the surface. So having said this, if I extend the question like this, if at all in your exam they put a question like this saying, what is the charge present inside? What will the answer be? What will be the charge that is present inside? Q enclosed is how much? Correct. It's 0. Because total flux is equal to charge enclosed by epsilon naught. When total flux is 0, total charge enclosed is 0. See, does that mean that the charge inside is 0? No. The total charge that is present inside is 0. Shall I proceed?
Yes, sir.
Okay. So careful measurement of the electric field at the surface of a black box indicates that the net outward flux through the surface of the box is found to be 8 into 10 power 3 Newton meter square per coulomb. What is the net charge inside the box? So Q enclosed is equal to 5 into epsilon naught. So it is 8 into 10 power 3 into 8.85 into 10 power minus 12. That's the answer. So multiply this, you will have an answer approximately 64 into 10 power minus 9 coulomb. I ignored that 8.85. If the net outward flux through the, see, this is what I explained in the previous problem. If the net outward flux through the surface of a box were 0, would you conclude that there were no charges inside the box? If the total flux through a cube had it been 0, according to Gauss law, what are we trying to say? The total flux is equal to charge enclosed divided by epsilon naught. So if this is 0, Q enclosed will be 0. So what they are asking is, could you conclude that there were no charges itself, meaning the charges present inside were 0? You cannot conclude that the charges were 0. Rather, you can conclude that the total charge that was present came out to be 0. When you apply the additive nature, the charges were placed in such a way that the total charge was 0. Meaning, you could have had 2 positive charges, 2 negative charges of the same magnitude, or you could have had only 1, or you could have had something like this. But what is happening in either of the case? When you sum up the values, the answer is coming out to be 0. Right? Number of field lines entering will be equal to number of. If something has to come out, something has to go in, right? What did they say? They use the word net. Need not, it is not necessary that everything is entering. They are saying the net flux that is considered within a shape is 0. See, for example, if I had a situation like this, let's say I placed a dipole, then due to this dipole, the number of field lines emitting out would have been equal to the number of field lines entering. So they are concerned about this point. Like they're saying, what about the net value? The net outward flux through a surface of a box was 0. Can you conclude that the total charge that was present inside is 0? Is what the meaning. So if had the total charge been 0, first of all, you cannot talk about the outward flux. Okay. The 18th one. A point charge 10 microcoulomb is at a distance of 5 centimeter directly above the center of a square. A point charge 10 microcoulomb is at a distance of 5 centimeter directly above the center of a square of side 10 centimeter as shown in figure 1.34. What is the magnitude of the electric flux through the square? So I think you will have a square like this. So there is a point which is at a distance of 5 centimeter from the center of the square. Am I right? And what is the magnitude of the charge that is placed here? It is 10 microcoulomb. Right. What is the magnitude of the electric flux through the square? So what you can do is, what shape can you assume to be symmetric with respect to this charge distribution? You have a square. So what is the shape that can be built with the help of squares? It's a cube. So what you can do is, you can assume that you have a cube present here. Right. So when you assume that there is a cube present here, then the cube is considered in such a way that this 10 microcoulomb is exactly at the center of the cube. Then what is going to be the total flux through the cube? It will be Q divided by epsilon naught. So what is the charge enclosed by this Gaussian surface that we have considered? It is 10 into 10 power minus 6 divided by epsilon naught. It's going to be 10 power minus 5 divided by epsilon naught. Am I right? But this is the total flux through the cube. But what are they asking? What is the flux through the square? So square is 1/6 of the cube. So flux through one of the squares is going to be 1/6 of this value, that is 10 power minus 5 divided by epsilon naught. So it is 10 power minus 5 divided by 6 times epsilon. That's it. That's what they've given in the hint also. Think of the square as one of the faces of the cube of h 10 centimeter. Why they told you consider a cube of side 10 centimeter is because this distance is 5. You need to consider the size exactly double that. Clear? Shall I proceed? So point charge 2 microcoulomb is at the center of a cubic Gaussian surface, 9 centimeter on edge. What is the net electric flux through the surface? So if you see, this is a very, very simple problem. So charge enclosed by the Gaussian surface is 2 microcoulomb. Right. So you need the total flux through the closed surface. So total flux will be equal to charge enclosed divided by epsilon naught. So this is 2 into 10 power minus 6 divided by epsilon naught is 8.85 into 10 power minus 12. Right. Calculating this is going to give us the total flux. That's it. That's what they asked. Those who are online, are you clear?
Yes, sir.
Yes, sir.
So how many more are there? 4, right? They are very simple. We'll finish off. So 1.2. A point charge causes an electric flux of -1 into 10 power 3 Newton meter square per coulomb to pass through a spherical Gaussian surface of 10 centimeter radius centered on the charge. Okay, this is one thing. So listen to this. If the radius of the Gaussian surface were doubled, how much flux would pass through the surface? The answer will be same 10 power 3 Newton meter square per coulomb. Because the initial flux was -1 into 10 power 3 Newton meter square per coulomb, right? How much ever you are going to increase the value of the Gaussian surface dimension. As long as the total charge enclosed within it is going to be the same, nothing will change with respect to flux. That's it. Right? What is the value of the point charge that is present inside? Very simple again. So charge enclosed is equal to flux multiplied with epsilon naught. So flux is already 10 power 3 into epsilon naught is 8.85 into 10 power minus 12. Answer will be 8.85 into 10 power minus 9 coulomb. But the only thing is here it is going to be negative. So the meaning of minus is the flux is entering the surface. So which charge has the tendency to pull the electric field lines towards itself? It's the negative charge. Here. Shall I proceed? You copy? Done? So what is this question telling me? A conducting sphere of radius 10 centimeter has an unknown charge. So charge is equal to how much we don't know. If the electric field 20 centimeter from the center of the sphere is 1.5 into 10 power 3 Newton per coulomb and points radially inward, what is the net charge on the sphere? On charge, if the electric field 20 centimeters from the center of the sphere is, okay, so electric field is found to be 1.5 into 10 power 3 Newton per coulomb and points radially inward. So we know that electric field due to a conducting sphere is given as 1 divided by 4 pi epsilon naught into Q divided by R square. Right? So this is going to be 9 into 10 power 9 into what is the value of charge? That's what we need to find, divided by R square. R square is 20 centimeters. So it is going to be 20 into 10 power minus 2 or 2 into 10 power minus 1, the whole square. Right? Electric field is known. How much is it? It's 1.5 into 10 power 3 is equal to 9 into 10 power 9 into Q divided by 4 into 10 power minus 2. So 1.5 is 3 by 2. This will cancel this 6 times. This will go 3 times. This will go 2 times. Take it to the other side. So 2 divided by 3 into 10 power 1 into 10 power minus 9 is equal to the charge. So charge will be 0.67 into 10 power minus 8 coulomb. It is 0.67 into 10 power minus 8 coulomb and it is a negative charge. Right? Because they told it is pulling the electric field towards itself. They are radially inward. It's a negative charge. Am I clear with this? 0.67 into 10 power minus 8 coulomb. I'll do one last problem. Remaining you guys can try it. I think there are 2 more problems that will be left out. You can do it. I'll finish this. So done copying?
Yes, sir.
Okay.
Yes, sir.
So let's look at this. A uniformly charged conducting sphere of 2.4 meter diameter has a surface charge density of this much value. So sigma is equal to 80 into 10 power minus 6 coulomb per meter square. Find the charge on the sphere. So Q will be equal to sigma into A. So sigma is 80 into 10 power minus 6 into what is going to be the area. So since it's a sphere, area is going to be 4 pi r square. Diameter is 2.4. So the radius will be 1.2 the whole square. So when you solve this, this is going to give you the amount of charge that is present. Right? Next is, what is the total electric flux leaving the surface? Since they told it is leaving, it should be a positive charge. So what is going to be the flux that is leaving the surface? Once you find the charge, right? Once you find this Q, right? Q divided by epsilon naught, that will give you the total amount of flux that is leaving the surface. Is that point clear? Yeah. So those who are online, I hope it is clear, right?
Yes, sir.
Yes, sir.
So there are 2 more problems left out, which you guys can try it out. If you have any doubt, reach out. So tomorrow I'll be starting the next chapter. Right. And like I mentioned yesterday, I want you all to work on the pre-recorded content as well, so that we can solve more problems in the class. Right.
Okay, sir.
So that's it from my side for today. I'll wind up. Yeah, those who are online can be.
Thank you, sir.
Thank you, sir.